An interesting question is, what is the maximum number that we could store inside 1 byte in memory? So what is the largest number we could store? So obviously if we have zeros for all of this byte, so if everything is 0, then this in base 2 would be 0 in base 10. There's no difference. Now let's say that we put a 1 into all 8 bits. So we've got to think about what each of these columns is. There's the 1s column, the 2s, the 4s, the 8s, the 16s, 32s, 64s, and the 128s column. So essentially what we're saying is it's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And if you add all of those together, that comes to 255, which is a very common number to see in computing because 1 byte stores the numbers from 0 in base 10 up to 255 in base 10. And that's why if you look at things like on your monitor, then the amount of red, green and blue, especially if you're doing things like HTML, you'll see that each of those, because there's 1 byte to say how much red, how much green, how much blue, what you're going to get is the values from 0 to 255 for red, and from 0 to 255 for green, and the values from 0 to 255 for blue. And that's why they chose those numbers. It wasn't pure luck, it was because if they have 1 byte to store it, then they'll have the values from 0 to 255. Now the next thing we're going to do is to look at some fairly simple denary to binary conversions. So the first one we're going to look at is 7. So what you want to do first of all to convert these from one base to another is put in what the columns are. Just like when you were a young child, you would have done the 1s and the 10s and the hundreds column. Just do the same thing. So you're doing base 2, so it's the 1s column, the 2s column, the 4s column and the 8s column, and so on. We don't need many columns because we've only got 7, but we will put in the other columns because we'll need them later. So 32, 64, 128. Okay, so we've got 7, so we need to look at the first number which is smaller than 7. And the first number which is smaller than 7 is 4 here. So all of these others will be 0. We don't need any of them. We do need 4 though. So if we now say 7 minus 4 gives us 3. Now 2, so we can put 2 into 3, that works, that's the next smallest. So we need a 2. So 3 minus 2 equals 1. And we've got the 1 there. So we've got 4, 5, 6, 7. So the answer to what is 7 in base 10, it's 111 in base 2. Now let's look at 18. So again, we need the numbers 1, 2, 4, 8 and 16 and 32. I won't go any further. So 32 won't fit into 18, but 16 will. So we'll take one of the 16s, and then 8 won't fit into the 2 that remains, neither will 4, but 2 will. So 16 plus 2 is 18, and we don't need any of the 1s. So 10010 in base 2 is the same as 18 in base 10. Now we want 183, big long number, so 1's column, 2's, 4's, 8's, 16's, 32's, 64's, 128's, and then we don't need the 256 beyond that. So we're only dealing with 1 byte here. So 183, well, we've got 128. So we can take 183 minus 128. So that is 55. So we're now looking, 64 is too big, it won't go into 55, so we don't need any 64s. But 32 will go into 55, so we'll have 132. So let's take 32 from that, and that leaves us with 23. So will 16 go into 23? Yes, it will, so we need a 16. So let's take the 16 from that, which will be 7. Now 8 can't go into 7, so we don't need any 8s. But 4 can go into 7, so we'll take off the 4, and that's going to leave us with 3. Can 2 go in? Yes, it can, so we'll take off the 2, which leaves us with 1, and then we just have the 1, and there we are, finished. And let's just double check that this works. So in order to double check, what we want to do is add up the different numbers that we have. So it's 128 plus 32 plus 16 plus 4 plus 2 plus 1. So we have 2 plus 1, which is 3, 3 plus 4, which is 7, 7 plus 6, which is 13, 15 with the 2, 15 plus 8, which is 23. And we've got 3, 4, 5, 6, 7, 8, so that will be 8, 3, and we've got the 1 here, so that will be 183 in base 10, which is the figure we were looking for here. So what we want to do now is to look at the number 254, and we want to do this a slightly different way. We could do it by just doing the 1248 and doing exactly the same as we did 183, and there'd be nothing wrong with that, but it would take a little while just to add up these numbers. So we're going to use a little trick, because 254 is almost the same as 255. So let's clear a little space here and have a look at how we can do this. So what we can say is we do have the numbers 1, 2, 4, 8, 16, 32, 64, 128. And we'll also put in that we have 256. Now 255 would be where I fill up all of these. So it's one less than 256. So that there is 255. And what we're asking for here is 254. So if we take 1 away from 255, in other words, if we take this 1 here away, we will get 254. So it's 1, 1, 1, 1, 1, 1, 1, 0 will be 254. And if you don't believe that, or if you got confused as to how that works, just try doing it the method we did in 3, and you'll see that we come out with 254 there. The final calculations which we're going to take a look at are from binary to denary, so going from base 2 to base 10. And these are relatively easy. All we have to do is label up the columns at the top in order to work it out. So that's the 1s, the 2s, the 4s, 8s, 16s, 32s, 64s, and the 128s. So we've got one of the 1s plus a 4 plus a 16 plus a 32 plus a 128. So 128 plus 32 makes 160, plus the 16 and the 4 is 20, plus the 1 is 21. So that will come to 181. The second one, number 2, again we want to label them up. So 1, 2, 4, 8, 16, 32, 64 and 128. So we've got 132 and we've got an 8 and a 4 and a 2. So 4 plus 2 is 14, 16 plus the 3 is 4, which is 46 in base 10. Let's just put the base 10 there. And we'll just clean some of the board up so that we can do number 3. So once again, you want to put in the columns . Okay, and here we go. So we've got 64, this is a really easy one, plus 1. That's going to be 65 in base 10. And the final one here, we've got 1, 2, 4, 8, 16, 32, 64, and 128. So this is going to be 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1. What we'll also notice here though is all that we're missing is the 32. So we know if all of these were full, that would be 255, but we don't have the 32, so it's actually 255 minus 32. And so that gives us a remainder of 23, so it's 223 in base 10. And if you're not convinced at that number there, then add up all of these numbers over here and it should equal the same value.